In this lecture, we're going to look at what happens when we have two carbon atoms or two of the same element attached to a stereocenter, and we're trying to assign R and S. So this is kind of like what happens if there's a tie amongst the atoms that you're trying to prioritize. Which one usually gets the 1, the 2, or the 3? It's usually 4 is always kind of is many times hydrogen. Well, you know, the reality is, let's just kind of get into it. What I'm really asking is, what happens? How do you prioritize the groups if there is a tie? And it's the groups on a stereocenter. So the groups on a stereocenter. And just to set us up for R/S assignment, when there is a tie. Now, here's the kicker. This isn't like one of these one-off questions that you have to deal with sometimes. The reality is that there's always a tie. And what's the element that always provides the tie? It's carbon. Now, I'm not saying there's always a tie, like a universal rule that there always has to be a tie. It's just that we're using this to understand the stereochemistry of organic molecules. And so with that in mind, organic molecules many times have multiple carbon atoms attached. And so we have to recognize that there's going to be a tie amongst, because there's carbon atoms present everywhere. Okay, so how do we approach this? What we need to do is kind of step through the elements and basically compare the next highest priority elements attached to the atom of interest. Okay, so we compare the next highest priority elements attached to the atom of interest, and really that is to say the tied, let's write it this way, tied elements. Those elements that were, they're the same, both carbon atoms in many cases, okay? So we need to kind of compare the next highest priority. Let's look at an example of this. So let's have bromine facing down today. So we've prioritized this one a few times, and we said that when we have a methyl group and an ethyl group, yes, the two carbon atoms tie. So maybe we put a star and a square here. Yes, the two carbon atoms tie, but the ethyl group gets higher priority than the methyl group. Now, why is that? Well, if we look at the various elements, we have Br is greater than C star, which is greater than C square, which is still greater than hydrogen. So we go 1, 2, 3, 4. Now what I'm saying is let's kind of figure out why we have C star beating C square. Well, what I like to do is have like a little breakdown where I'm going to say, okay, C star has what attached to it? Now I'm going to list the things that don't include the stereocenter, because the stereocenter is always the same. So C star has what attached to it? It has a hydrogen, and a carbon that's attached to a CH3. So I'm going to list those 3 elements that are attached to that first carbon atom that I happen to be looking at. So it's C, H, H, okay? So the C, this was the CH3 atom. It's not the stereocenter that's attached to the bromine, because both of them are attached to that. Now, C square is attached to H, H, H. Now I want to write the atoms that my tying elements are attached to in kind of priority order in case there's a second tie. And we'll get to that in a second. Well, if I do that here, I've got H, H, H. Now what you do is you go down the line and you kind of compare these. So it just so happens that the C star has a carbon atom attached to it, and that's the second highest, or that's the highest priority element that's attached to that C star, not counting the carbon with the bromine. Okay, now C square, not counting the carbon with the bromine, C square only has 3 hydrogens attached to it, so the highest priority element would have to be a hydrogen. Now C beats carbon, and as a result, if C beats carbon, then C star beats C square. Okay, so that's sort of how you play this game. I like to just have the 2 tying elements and then write the 3 atoms that they're attached to. Okay, so what if the tie goes even further? Let's say we've got, excuse me here. Let's put a bromine on. Let's look at this scenario. Now, in this scenario, we have hydrogen gets the 4, bromine gets the 1. Now we're comparing an ethyl group to an ethyl with an OH. And, you know, in this case, now we have to compare these 2 carbons, and I'm going to label star on the left and square on the right. Sure, whatever helps you. So we have C star and we have C square. Now attached to those, we have if you look, it's a CH2 with another carbon, so it goes CH. Okay, now over here, we've got attached to that 2 hydrogens and a C, so that's CH. So now what we do is kind of go down the line. If we compare these 2 carbon elements together, we get another tie. So then we're going to compare these elements together, and we have another tie. If we compare these 2 elements together, we still have a tie. So we weren't able to break the tie between star and square, going from just the highest priority elements attached to those 2 elements that are tying. So we have to continue onward. If both elements have the same direct attachment, move on to the next C atom. Now, why do I say C atom? Well, C atom, if the C atom is usually going to have something different attached to it. Remember, if we keep tying, then, excuse me, then the 2 groups are going to be the same, and we're not going to see chirality because we need to have 4 different things attached to it. So we need to move on to the next carbon. Now, what that's going to be is that's going to move from C star and C square were yellow. Now we're going to have like C star and C square purple. So we've got C star yellow attached to C star purple, and C square yellow attached to C square purple. So we just have to kind of continue onwards. We're moving towards the carbon atoms now. Okay, so if we go down this route, let's see what's attached to these things. So to C star, we've got 3 hydrogen atoms. H, 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 it doesn't matter what order we list them in. And then in C square, we've got H, H, and then OH. Now the O gets the highest priority, so that gets listed first. And now as we compare the highest priority elements attached to these things, we get an oxygen beating a hydrogen atom. Okay. So that means we're going to see C square get the higher priority. And if we prioritize the groups attached to our molecule, I'm going to redraw it down here. Okay. We're going to see that bromine is 1, hydrogen is 4. Now C square gets 2, and C star gets 3. I'm going to make sure that I label the elements directly attached to the stereocenter. Okay, I think it's helpful to keep looking at examples. Now, what if we take that molecule with its OH, and we add another carbon atom. So on the side of C star, we've added another carbon element, but on the side of C square, we've left that the same. Notice that oxygen always beats carbon, right? But that's not the game we play. We move from direct attachments to the next highest priority, directly attached. So we're going to go back to our yellow atoms and sort of reanalyze this. We have C star and C square. I'm going to continue to color these yellow. Now, what's directly attached? Well, we have C, C, H now directly attached to C star, right? We've got CH3 going up, CH3 going down and to the left, and then the H. So I put those in order of highest priority first. So comparing carbon to hydrogen. And then if we go C, H, H, this is the same as what we saw before. That is the yellow carbon on the square side. Maybe I should have moved that so it's consistent. But the yellow carbon on the square side still just has 2 hydrogen atoms attached to it. Yes, there's a bigger group, a bigger element than all of the carbon atoms downstream of C square, but that's not what we do. We compare first these 2 elements. Whoops, sorry. These 2 elements, and we see that there's a tie. But then we move on to the next highest priority element directly attached, and we see that carbon beats hydrogen, and so C star gets the higher priority, which in this case is 2, and then C square is 3. So 2 and 3. So you just kind of slowly step out. Now, if we look at yet another example, what if we have this example? So bromine gets 1, hydrogen gets 4. Okay, so we have this example. Now, what we have is another tie. We've got star and square. I'm just going to keep calling these like left and right, left being star, square being right. So C square and C star, let's pit them against each other head to head. Okay, so attached to C star is carbon, carbon, hydrogen. Now C square has in this case a fluorine, then 2 hydrogen atoms. So if it got to the second element, we would see that carbon beats hydrogen in that case, and that would give star the higher priority, but that's not what we do. We go to the first highest priority element directly attached to the tying elements, and that's going to be carbon versus fluorine, where fluorine is better than carbon or higher priority than carbon. So we're going to get 2 here and 3 here. Okay, so we just did a bunch of examples and we didn't assign RNS to any of them. That's my fault. Let's go ahead and do that really quick. This is good practice. Okay, so if we've got, going to our first example where we had, I think I redrew this down here, didn't I? Did I? Oh, well, I didn't. Okay, so this first example was one that we saw previously. So 1, 4, then 2 and 3. So we go with 1 to 2 to 3. That's counterclockwise. No, that's clockwise. Oh my gosh, I need a digital watch. Holy cow. Okay, so that's R. I'll say my counterclockwise, clockwise assignment in case there's an error in the lecture. So we have 1, 2. I guess this one's drawn down here. So we go 1 to 2 to 3 is going to look like this. Starting at 1, ignoring 4, 2 to 3. That's counterclockwise. And so that assignment is going to be S. Then over here, we go 1, 1 to 2 to 3, and that's going to be R. And then over here, 1 to 2 to 3. You can see how I kind of glazed over this because once you do the priorities, you've done the hard part. That one's S. Once you've done the prioritization and rolled the molecule so that hydrogen's in the back, then you've really done the hard part of all of this. The next thing I want to consider is what about double bonds and triple bonds? So double bonds and triple bonds, these are sort of, let me just say it this way. A double bond is the same as as being bonded to two of the elements. Okay, so really good example of this. And then we should say the same thing for triple bond, but we should get right into examples. This is a little bit awkward of a rule to write actually in words. So triple bond is the same as being bonded to three of the elements. Okay, let's go ahead and get right to examples of this. So if we had a molecule like this, we have hydrogen in the back, that's number 4, but then we have a carbon atom, and a carbon atom. And let's go star, circle, square. So we have tying elements in terms of their raw atomic mass, star, circle, and square. Now what's attached to each of these? Well, if you look at star, it has 2 hydrogens, right? So we have a carbon and then a hydrogen and then a hydrogen. Now for circle, circle has 1 hydrogen, but then it's double bonded to a carbon. So circle really looks like this, like it only has 2 things attached to it. Well, that's hard to make that direct comparison because what do we do about this block? Well, we assume that we have a second carbon. So assume a CC double bond equals 2 carbons. So that is to say that this carbon appears from the fact that we've got a double bond between the 2 carbons. So this first carbon, which I will temporarily shade purple, that corresponds to this carbon. Okay, it's real. Let me say it that way. That carbon is real, like you can actually put your hands on that element. The yellow carbon is sort of made up to take into account the fact that we've got a double bond between those 2 elements. And so down here with the triple bond, we have a carbon and that's it, right? I mean, at C square, we're only attached to another carbon, which is attached to a hydrogen. So this hydrogen here that I'm underlining, that carbon that I underlined is real, but that's the only thing that's attached to that other carbon, to carbon square, because there's a triple bond. So what we do is we just imagine that there's 2 more carbons so that we have a total of 3 carbons because we're triple bonded to a carbon. We assume that is the same as having 3 bonds to a carbon, and then a double bond assumes that we have 2 carbons attached to carbon dot in that case. And so as a result, for prioritizing this, we would give 1 to the carbon triple bond, 2 to the carbon double bond, and 3 to the carbon single bond. So we go 1 to 2 to 3, and that is S. So that one's S, and that's kind of how you play the game with double bonds and triple bonds and that sort of thing. Let's do another example. So let's assume that we've got let's go back to bromine and hydrogen. I'm going to put a benzene ring on one side and then this molecule on the other side. And so bromine gets 1, hydrogen gets 4. But now we have 2 and 3. So 2 is going to actually be the benzene ring, but let's look at why that is. I'm going to label, well, I guess I was doing square on the right and star on the left. So C star, if you look, we've got a carbon and then another carbon. Where's that second carbon coming from? It's actually physically only attached to the one carbon. That second carbon's coming from the double bond, as we just said. Whenever we have a double bond, we just assume it's actually bonded to 2 of those elements. In this case, it's double bonded to carbon, so we assume we have 2 carbons as we're doing the priorities, and then a hydrogen. Whereas C square, we've got a carbon, and then a made up carbon from the double bond, and then a third carbon. So it's the third element, the carbon and hydrogen, that allows us to see the difference between these two, where the benzene ring will get the 2. So we get the 3. If you draw our, I guess I'm selecting green. If you draw our green arrow, this looks to be an S stereocenter. Okay. So you can play this game with all sorts of atoms. You can go for, you can actually do this with oxygens too. So let's say you've got oxygen, double bond to oxygen, and then let's do, yeah, I can't do triple bonds, can I? So yeah, let's do this example. Okay, so hydrogen is the 4. So we've got a carbon-oxygen single bond. We've got a carbon-oxygen double bond that also has a second oxygen on it, and then a carbon-oxygen double bond, which has an implicit hydrogen attached to it. So how do we assign this? I'll let you kind of think through for a second. You can pause the video. Okay, so this was supposed to be sort of a trick. Just to remind you, we're going to go directly attached. And so if we go directly attached, we're comparing an oxygen to a carbon, to a carbon, to a hydrogen. So oxygen always wins the day. So I guess I was just trying to catch everybody sleeping. So oxygen wins the day as the highest priority element. Hydrogen is number 4. And then what we have are 2 carbon elements. These are tying elements. And so we have to look at what's attached to the carbon elements. I'm going to put star, continue to put star on the left and square on the right. So we have C star and C squared. And I guess I dotted these yellow. Now what's attached? Well, to star, we've got oxygen, oxygen, and that's because we have a double bond. So that second one is sort of made up. It allows us to properly prioritize the double bond in the presence of other single bonds, and then we have a hydrogen atom directly attached versus oxygen, oxygen, oxygen for number 3, where, or excuse me, C square, where that second oxygen is made up, the third one is real. Okay, in this case, then we would see that 2 is that priority, 3 is there, and we go 1 to 2 to 3. That looks to be R. Yeah, you got to be careful. It's not just the clockwise rotation. It's the making sure you write the right letter, I guess. Okay, so we practice a lot of R and S stereocenters. That's kind of the way to play the game, is to just do a bunch of stereocenters, look at the weird ones, and then prioritize. Every time you're going to see a tie amongst carbon atoms, so make sure that you're able to pick out the, find where they differ and be able to prioritize them correctly. And it just takes some practice, but you don't want to rush through it. It's just kind of slowly building what is the highest priority element directly attached, and then from there start to just kind of comparing the groups. So anyway, hopefully this was helpful.